Well, hello everyone. It's been a while since we've seen each other and a lot has changed. In today's video, I want to talk with you about how the role of a developer is changing in the age of AI. It's a cliche phrase, but there's really no better way to put it. AI, artificial intelligence, neural network models, all of this is just buzzing and hyped up in our infosphere right now. And for us, regular developers, it would be good to understand where all of this is heading. I sometimes make videos like this. I think you saw them in the previous video. I was pretty outspoken about what's happening in the field right now. Today, I'll try to make a video with less information about specific tools or approaches, and instead, I'll just reflect more on what has already changed and what to expect in the future. In particular, we'll talk about what beginners and junior specialists should do and where all of this is heading. Basically, it's going to be a conversational video. Some might say it's just going to be a lot of talk, but since for the past 2 years, I've basically been teaching developers how to work with AI, and I've been working with AI myself for over 3 years. Plus, I've been in IT since 2011. I think my thoughts are worth listening to, especially considering that for the past several months or even a year, I've been following the news every single day, picking out the updates that are most relevant for developers, translating them into practical information that engineers then absorb in the companies where I help with AI transformation, and in the communities where I serve as a leader. Basically, the same thing is happening everywhere. I filter through a ton of information related to AI development, and as a result, I have a number of thoughts to share. There will be timestamps in this video so you can navigate directly to the sections you want. If someone is here to hear about what will happen to junior developers and how juniors should adapt to this new reality, you can jump straight to that timestamp. But overall, I think it will be useful for everyone to listen to the current changes. New professions. Have they appeared or not have new professions emerged in IT with the advent of AI? Well, let's just say they have appeared. A number of professions have emerged that have caused a lot of buzz and hype, but which aren't taken very seriously within the developer community. At the same time, there have also appeared some fairly, well, let's say, engineering professions that are directly related to AI and which we can discuss in a more concrete way. I'll try to talk about the main ones. Among them, probably it's worth starting with... No, not with Vibcoders. We'll talk about Vibcoders separately at the end. I have an interesting opinion about them too, but with the prompt engineer. So the profession of prompt engineer, and I put profession in quotation marks, in my opinion appeared about 2 years ago. As soon as our model started to write at least some code, like that very first Snake game I showed you about 2 years ago, immediately, I would say the media picked up and spread this term prompt everywhere. And since prompts and the models that use them are made by engineers, they were originally created by engineers working with the first models, was mostly an engineering geeky thing, for the most part a geeky pursuit. That's why I think the media assume that, well, this is something really geeky. And who are geeks? They're engineers. And of course, all engineers are geeks. For the record, I don't think so. And so in the end, they say, well, that's it. A prompt engineer is someone who formulates prompts correctly so that the model works as intended. What can I say about that? Today, I can say that prompt engineering does exist as one of the subfields of knowledge that the average developer possesses nowadays. I actually recorded a video about this for my English language channel, about the next profession we'll discuss, context engineer. In that same video, I also talked about prompt engineers. I called it common sense for a developer, for an engineer. So today, a programmer who works alongside AI, who has AI tools, knows how to write prompts. And prompts are just messages. They came up with a complicated word for a simple concept. So if you know how to write messages to a model in a service in such a way that the response is useful, meaning you can extract something valuable from the model using messages, prompts, then you can basically call yourself a prompt engineer. Well, that's how I see it. Any programmer who knows how to work with a cursor, with any other tools, with cloud code, and does it efficiently, not just burning through tokens, but working effectively is, by definition, a prompt engineer. They know how to write prompts, they know the basic prompt techniques, and there aren't that many of them. Some people figure them out on their own, others read about them. Basically, it's about properly formatting your message, your prompt, in order to get the result you need. And by the way, with LLMs, with text models, this is actually a really simple thing, especially in programming. We just need to write messages clearly enough. That is not the way we usually do. Like, I don't know how seniors throw things at juniors in chats. Go do this, I don't know what. Okay, not seniors, managers, do this, I don't know what. Of course, communicating with models like that is, well, not the best idea. Provide as much information as possible, follow certain rules, sometimes specify an actor, describe the type of response you want, include context, mention the programming language, give context about the project in general. This is already common sense, common knowledge. More or less in any company that is implementing AI, developers either learn these things on their own or adopt the experience from external developers. For example, I consult for several companies this way. I just run workshops, show how you can work with LLMs, what use cases LLMs can address. So specifically tasks like writing tests, documentation, developing small features, automating testing, implementing various security checks, all the AI pipelines. These are the kinds of things I'm talking about. All of this, in one way or another, is fundamentally tied to prompt engineering. You need to know how to write a task, not just correctly, but in the most efficient way possible, how to describe the task so that you don't have to send hundreds of prompts and spend, say, 20 hours, but instead just send one prompt to the language model and get your answer. Or even better, you send the properly formulated task to an agent system and the task gets solved. That's essentially what prompt engineering is all about. Some might say that prompt engineering also includes skills like effective prompting, tuning the model for a company's needs, creating prompt libraries, and testing those libraries and models. I would say that's already a broader task. A prompt engineer is simply someone who knows how to craft high-quality messages for models or agent systems. If you're already working on testing the effectiveness of your prompts, that requires setting up special systems that allow you to evaluate it, to do evaluation, basically to compare the quality of different prompts on the same tasks. If on top of that, you can also configure the model yourself, change some global parameters, maybe even fine-tune it or distill it somehow, then, those aren't prompt engineering skills anymore. That's a specific area of ML, sometimes even bordering on deep learning, and it also involves a good deal of data engineering. Let's be honest and call such people not prompt engineers, but data engineers, deep learning specialists, or machine learning specialists. These specialists, of course, work with pipelines and models every day, and naturally they have a fundamental understanding of how to properly interact with the models and systems they configure, but they are not prompt engineers. In general, as a profession, prompt engineer does exist. Yes, there are some, well, not just some, there are companies on the market that hire prompt engineers, but in reality, for these companies, these are people who simply adapt prompts for their business needs and compile some libraries of these prompts. Occasionally, these people also make prompts variable, that is dynamic. For example, you can write a program that will insert a particular variable into the prompt depending on certain external factors. This too can be considered as part of prompt engineering. But as you can see, once again, this is just an ordinary programmer doing the usual tasks who has made a little tool for themselves that improves their prompts using certain variables. So again, this is all about engineers. A prompt engineer as an abstract concept in a vacuum does not exist. There are no universities that train prompt engineers. To be a prompt engineer, you first need to be an engineer programmer. And then in just a few days or maybe weeks, you can learn to write quality prompts for your specific domain, and then you'll be a prompt engineer. But this is not a separate profession. Today, it's a basic skill for any developer working at a company that is undergoing or has undergone AI transformation. Recently, the term context engineer has appeared. It was introduced by the CEO of Spotify's name, escapes me right now, but I'm sure someone will remind me in the comments. And also by Andrej Karpathy, who came up with the coder vibe. In general, he's a very smart guy, one of the co-founders of OpenAI. He worked at Tesla, and he explained what this is all about. So what exactly did Andrej Karpathy say? He said that prompt engineering works so that context engineering could run. In other words, context engineering is advanced prompt engineering, according to these guys. So what does it involve? Again, for me, context engineering is just common sense, basic common sense for an engineer working with AI. Sooner or later, when you start working closely with AI systems, with code, with agents, with code generators that can already write features for you out of the box, or that work with large chunks of code, you eventually realize that it's not so much about which prompt technique you use, but rather about what context you provide as input and which models and tools are being used under the hood by your agent tool. And accordingly, at this point, you need to have a better understanding of your project's business model and domain area. Because if you don't know the domain, you won't be able to provide proper context. I remember the time when it was cool to write code for the sake of code. I mean, to write beautiful code just for the beauty of the code itself. And you could get by with that because managers would provide enough information as input. Most developers didn't really need to understand the domain area deeply. Although, of course, from the beginning, people who understood the domain were valued. But the ones who became chiefs and architects weren't those who wrote beautiful code just for the sake of it, but those who also had a good grasp of the domain. That's why understanding the domain has always been a solid foundation for growth. But when it truly comes to effective context engineering and working with powerful AI tools, you now absolutely have to deeply understand the specific domain in order to provide the necessary task context effectively and comprehensively. It's not enough to just write, make me a new method that follows solid single responsibility, open close Barbara Liskov principle, all that, and make it easy to test. No, that's not enough. AI will likely write you some nonsensical gibberish, but it absolutely won't actually solve any real-world business problems or provide practical solutions. It used to seem like tasks were divided into very small pieces. Today, I see a trend where with AI tools, we can just take a fairly broad business requirement in the language of, say, some Scrum Masters. It could be an entire user story. We can take a user story to the developers and throw it into an agent. The agent will write the entire code for the whole user story for us. And to figure out how this code works and whether it works correctly, we need to have a really good understanding of what is being done in this user story from a business perspective. I remember well that before and even now, user stories are broken down into separate tasks. We groom all of this, then have a ton of calls, and in the end, the developer gets a really clear task. If the team lead is also really into micromanagement, the developer basically gets a detailed description of the input and output API. There was no need to understand the business. So before, you could work as a developer without really getting into the business side, just writing clean, extensible code at the middle or senior level, and that was it. And just sit there in the golden cage. Today, when working with AI tools, knowledge of the business domain context has become a higher priority. And so essentially a context engineer is someone who understands the domain well enough to provide the necessary context. And it's not just the domain you need to understand. You also need to understand, of course, the context of how your project is written. In other words, you need to be a bit of an architect as well. You need to know which libraries are used, what limitations the project has, what style guides you follow in general. You need to understand the project and the essence of how it works. Because if you don't provide the AI with at least a basic description of the entire module, even if you're only writing a small part of it with the AI simply won't know that context, whereas you've already internalized it subconsciously and don't pay attention to it. So you need to understand how your code works as a whole, how the system works overall, both from a business perspective and from a code perspective. And you need to neatly package all of this for the AI. It might seem like this is difficult, like you have to do it all the time, but in reality, most of this is done once and then updated as needed, basically. You create some project files. These are usually Markdown. False Markdown has become the standard for agents where the project is described and some typical cases are outlined explaining how they should be handled. Then these files are simply updated as the project grows, either manually by developers or automatically by AI. You might have heard of the memory bank concept that's popular right now. That's exactly what this is about. This is one of the main distinguishing features of a prompt engineer compared to a context engineer. Additionally, I would say that for a context engineer, or more precisely, for a software engineer who also wants to add the title of context engineer, it's important to understand how the model works under the hood. Not necessarily in exhaustive detail, like how matrices are multiplied, how the architectures are built, what encoders and decoders are, what vector space is. You don't really need to know all the theoretical details, but it's worth understanding at least the basics that affect how effectively you work with context. What exactly is a model's context window? What is an output context window? What is attention? How does this attention mechanism work? All right, attention is already a bit more advanced, but still you need to understand what context is, what the context size is, and with what context size the model you're using under the hood, the models can work effectively. What are tokens, and how does tokenization work for different alphabets? Because, for example, when you talk to the model in Russian, you'll hit the context limit much faster than if you're speaking in English, simply because Latin characters take up less space. That's because there are different tokenizers. So again, I just said that you don't really need to know about tokenizers, encoders and decoders, but it would be good to understand what tokenization is. Why is this important? Because, well, yes, in theory, you could just shove your entire project into the model, just take all the files, merge them into one, and feed it in. But if you don't know what context size is, that it's limited, what hallucination is and why it happens, then you just want to understand why. When you shove your whole project in, the model spits out some kind of gibberish nonsense. Why won't you understand why you need some kind of markdown files with a concise human written description of the project instead of just dumping the whole project in? Well, it's because our context size isn't infinite. The model can't keep absolutely all the code of your project in mind if the project is large. Right now, the average context size for a model, if we take the average for closed models, is about 100 to 200,000 tokens. 1 to 200,000 tokens, well, that might be enough for, I don't know, some kind of microservice. You can look it up online, find out how an English token corresponds to a character, or rather, not a character, but a word. You'll see that roughly 200,000 tokens is about 200,000 keywords. It seems like a lot, but it's actually not that much, especially if you know how the model works under the hood. And when we work with models and all the tools, HeyGen tools, they all use models as their foundation. Right now, I'm not talking specifically about interacting with the model, but rather about using the model under the hood of any tool in general. For example, it's useful to know that they are stateless. A lot of people don't know this. And then they say things like, it answered me several times, gave me, 400 characters in one response, then another 400 and another 400. So in the end, it gave me 1,200 characters, which is nowhere near 200,000 tokens. But it already started to hallucinate. So the model is crap, the tool is crap. And then you ask the guy, so how much input did you send? Turns out he literally crammed the entire microservice into a single file. There are such services, and this approach actually works for small projects. But he, took a huge project and just shoved it in, dumped it as is in several messages into the LM. And you tell him, you basically used up the entire context with your prompt. And he just sits there blinking, but the context is only for the answers. But that's not the case at all. The model is stateless. And during its response, it takes into account, during its predictions, if it's a transformer, it considers the entire conversation within the session, both what it replied and what you sent. Moreover, let's go further. Today we have reasoning models. Almost all new models are capable of reasoning, that is so-called thinking. Reasoning, simply put, is nothing more than when the model talks to itself and, in fact, consumes tokens. And these reasonings are often hidden behind a button. So to see the full reasoning, you usually have to click somewhere, and then the whole reasoning thread unfolds. And that's when you see where the tokens went. Reasoning is also, in a way, part of the dialogue. And models that reason consume context faster, but they perform better. This is something a context engineer also needs to keep in mind, because you are directly responsible for the quality of the answers given the specific context you provide to the model. So the difference between a context engineer and a prompt engineer is that the context engineer has a better understanding of the tools under the hood, the models being used, and a deeper grasp of the business domain and how the project works as a whole. A bit of an architect, a bit of a business developer, a bit of a machine learning specialist. Sounds complicated? Yes, it does sound complicated. It even seems like it could be a separate profession. But again, for now, in my opinion, a context engineer can't really exist in an abstract vacuum. You definitely need to be a software engineer or a machine learning specialist first. And then on top of that, you build up the knowledge to be able to call yourself a context engineer as a second title somewhere. Will companies start hiring context engineers separately? Well, considering how hyped everything around AI is right now, I think some companies will pick up on this trend and actually start hiring context engineers. But keep in mind, these are just regular engineers who have additionally learned how context works. By the way, there isn't that much knowledge involved either. I think that after a week or two of reading specialized resources, like, for example, in Code Evolution, we have tons of workshops and basic information. You can understand all of this. That's enough. So it's not like you need 2 or 3 years at university to become a context engineer. If you're already an engineer, a few weeks are enough for you to grasp all these basic concepts and start applying them. Some people also include knowledge of working with currently popular approaches in context engineering, like how to work with RAG. That is essentially, you could say, it's external memory for the model retrieval augmented generation. Some might even say that a context engineer should be able to build these RAGs. That's already a slightly more complex task. There, you need to understand what vectors are, what embeddings are. But again, these are things you can learn in a few weeks or at most a few months. What is NSP? What modern protocols are there? So this is but it's more about expanding the capabilities of your toolkit and context. Therefore, this probably won't be included in the concept of a context engineer. But what will be included, including the idea of how to expand the functionality of the tool you're working with, is the role of an AI assistant engineer. It sounds like a new profession, AI assistant engineer, or an engineer assisted by AI, someone who works in tandem with AI. But in reality, that's exactly where our profession as regular engineers is heading, racing there at almost the speed of light on a jet fighter. In a couple of years, every engineer will definitely be an AI assistant. Absolutely. Everyone, both those who program hardware and those who still write in old languages like Fortran. And what else do we have in those banks? God, I forgot what the last programmer was called on. Well, you get it, basically Visual Basics. Everyone. There will be some kind of AI toolkit everywhere, which will, in one way or another, help write boilerplate, write documentation, test, and be present in pipelines. And that's why, as developers, you'll definitely have to work with some kind of AI tool one way or another. In any case, you will be AI-assisted developers. And you'll still have to spend some time learning how to use the tools and, well, the databases. Of course, it's better to start doing this right now. There could have been an ad here, but no, the ad will be at the end. Let's continue talking about the AI developer assistant. The new norm for all programmers is the ability to speed up, improve actually, not just speed up, but to work with AI tools in such a way that they handle the routine tasks, while you focus on more complex and interesting problems that at this point still require full human involvement. There won't be a single developer left who works without AI tools. Well, I just don't believe that. Of course, you can argue in the comments that maybe somewhere they'll still exist, but I don't see the point if part of the work can be assisted by AI. And by the way, I'm not talking about replacing developers right now. That's a separate topic. Will AI replace developers, or will it ever replace them at all? I'm inclined to believe that it won't happen anytime soon. But in any case, everyone has to work with these tools nowadays. And that's only going to become more and more the case. So you could say that if you're already using something like Cursor Warp or any other similar tool, you can call yourself an AI-assisted developer. If during an interview you're asked which AI tools you use and you answer not really any in particular, well, that's not going to work out for you, because you'll be replaced by an AI-assisted developer who can say, I use this and that, even if they're not as skilled as you are. But we'll talk more about that a bit later. Now let's move on to the list. Actually, no, not the last one. Let's jump to some more straightforward and clear positions that have already emerged. These are AI head or chief AI officer roles. These are VP level and essentially managerial positions, but they come from engineering backgrounds. These are the people within a company who are responsible for AI transformation. This is happening from two directions right now. First, these people are focused on getting developers involved with AI. And the goal isn't for developers to become AI developers, of course. At these levels, it's all about the money. The logic is simple. A developer who works with AI works faster, more efficiently, and the time to market for tasks is shorter. That's it. time to market is faster, the task gets released, the feature is implemented in production more quickly, which means everything's great. So one objective is to transform development teams, maybe make them more compact in some cases, but not everywhere. But definitely to speed up time to market. Oh my God. Where did you come from, Fly? I started talking about time to market and the Fly showed up just like that. So on one hand, transforming teams is a task, well, maybe not specifically for the chief AI officer or the head of AI, but at least for their subordinates. The second aspect is AI automation, business automation, implementing all sorts of AI systems for code linking, checking code for vulnerabilities using AI tools. There are tons of those. So basically it's about building up pipelines, right? Implementing tools for code review, which is actually also indirectly related to teams, but in reality it's about reducing the workload for part of the team, integrating with various Jiras and Confluences, so that developers can work more conveniently with these tool sets, including implementing AI solutions for non-production teams, for example, for account managers, accountants, support staff, automating certain processes. All of this is done faster, more efficiently, and more cheaply with AI. And these tasks are also handled by departments under the leadership of the AI head. So the transformation happens from both sides. On one hand, there's the transformation of development teams. On the other, there's the automation of processes with AI, whether those processes are within development teams or elsewhere in the company. So this is quite a good profession that already exists. The people I know in these professions are usually strong engineers, former architects, or former project managers with an engineering background who have a deep understanding of the AI landscape, or those who have done a lot of production work and suddenly grew into AI heads. In other words, they understand how this transformation can be carried out. And some people think of transformation as a process that you do once and it's done. And indeed, it used to be like that when, for example, teams switched to something like Git. They would hire a tutor or rather a consultant who would explain how to move the team from SVN to Git. Everything would be set up once and then they would work like that for decades. That won't work with AI. Here, transformation is ongoing because new models are constantly being released, new tools are coming out all the time, and new approaches are emerging. It's no longer enough to just solve one automation use case and then disappear for decades. Sooner or later, sometimes in months, sometimes in years, more effective tools for the same use cases appear, and they need to be implemented. This is exactly what the chief AI officer and their team are responsible for. So this is a permanent role, which, by the way, you could aim for. If you're already working with AI and hold senior or lead positions, one of the possible career paths is to become an AI head. I think it's even possible to jump straight into an AI head position from, say, a team lead role, bypassing architectural or strict management positions. After all, what's needed, there are people with hands-on experience working with AI, implementation skills, and an understanding of what the team and company need, rather than just good managers. But ideally, of course, it's someone like a product manager with strong engineering skills or an architect who has also developed management abilities. That way they can make the leap to AI head, build the team, and set up all these processes. But all of this is really about reducing the company's budget. This role is already the VP level, and regular developers don't always like it because we're used to thinking about solid, sustainable code implementation, while at that level, the focus is directly on saving money. And the last role, or rather, profession that should be mentioned is Vibcoders. It's not even really a profession, you could say it's a neologism. In fact, a neologism that was introduced into common use just about 6 months ago by the already mentioned Andrei Shkarpathy. So what's the point? The point is that quite a few people have appeared who, using AI tools without really knowing how to program or without wanting to delve into what the AI assistant is writing, are creating projects. That's why it's called vibe coding, from the word vibe. In other words, programming by vibe without getting into the details. You just give it a task, and the system gives you a ready-made solution. If you didn't like something, you wrote that you didn't like it, and often you just said it out loud. By the way, using your voice to work with AI tools like Cursor is already becoming a new trend. I'm trying to get myself used to it, but so far it's not going very well. So basically writing code without worrying about what's going on under the hood. The code works, the task is done, great, you vibed out the code and everything's perfect. This isn't even a profession, it's a calling. No, not a calling. It's actually a new form of programming. Because the code quality isn't checked and there aren't any no testing is done, it has a bit of a bad smell to it. Among developers, this bad smell is usually present. That is, many skilled developers, especially those who work closely with AI, know that AI systems do hallucinate from time to time, and they require constant supervision, code review, code completion, and code rewriting. These systems are still far from being able to independently write a large-scale corporate application, and even writing small applications without clear human guidance is quite difficult. And the bad smell comes from things like, so what kind of code did you just vibe out? Now your project is leaking, your transactions are failing, your packets aren't being fully sent. And there is some logic to that, yes. When the quality of your code determines, say, millions or even billions of your business's money, if you use the wrong variable, set up synchronization incorrectly, or mishandled parallelism, something leaks and bam, the company loses millions of dollars. Especially if your code is directly connected to human lives. If we're talking about safety systems, for example, self-driving assistance systems in cars, that's really not the place for vibe coding. There, you need to write code that you can read, extend, review, and generate tests for, and that's no longer about vibe coding. So as soon as you start reading what your AI assistant wrote and try to figure it out, that's where vibe coding ends. The classic definition of vibe coding is you give a task by voice or text and then run whatever code comes out. If the code doesn't run, you ask the assistant to rewrite it so that it does. So the classic definition of vibe coding is when you don't understand the code at all. You might not know programming at all, but you can still create products. And I'll explain to you later how to deploy them, set them up, and everything else. It can even do it for you itself. Moreover, as soon as you start understanding the code, thinking about whether it works or not, whether there are any critical issues or not, that's already regular AI-assisted programming, which I hope all of us are already doing. That's why there's a bit of a stigma. In the developer community, there's definitely a bit of a stigma around vibe coding, like it's not something serious. To be honest, I also used to have that attitude towards vibe coding for a while. I have my own projects that I program with AI for the club. We have a big bot and a few other projects, and that's definitely not vibe coding. Yes, AI writes almost all the code for me. I work with languages there whose syntax I wouldn't even remember if I had to write without AI. But still, I set the architecture, I review the code, and if it doesn't work, I figure out how to implement, say, a certain pattern, some closure or recursion in that language, trendy words, and I double check and implement all of that. So as an engineer, I mostly work as a code reviewer, but that's not vibe coding. But then there are a number of people who aren't from the programming field at all. Well, even among programmers, there are cases when you need something done quickly. You're a startup founder, a developer, and right before a demo, something in your MVP breaks. You just message some code assistant from your phone, whip this up for me, implement this bug fix. I mean, not implement, but fix the bug. And you don't care about quality because your product isn't working anyway. You have to pitch in 15 minutes. You don't have time to figure things out. If the AI assistant makes the bug even worse, what difference does it make to you at that point? Your project isn't even running. But if by chance it actually fixes the bug and commits code to the repo that works, then it's a win-win for you. So in these cases, vibe coding works for developers or some pet projects that don't really carry any meaningful, well, not meaningful, but aren't related to security risks. You can vibe code those just for fun. But now there are a number of engineers who don't know how to program, but programming would actually help them. And really the word engineer isn't just about being a software engineer. We sometimes forget about that. Engineers can be architects or, I don't know, people who build all sorts of hardware devices. They can be systems engineers or, I don't know, people who build robots. They can even be people who work with 3D graphics or CAD systems. In short, there are all kinds of engineers. I think you can list even more yourselves. By the way, write in the comments what other types of engineers there are who, generally speaking, haven't studied regular programming languages and don't really need them. I mean, I don't really see why you'd need to dive deep into programming languages when designing some simple 3D models. You know the plugins well, you understand how things work. You got a ton of plugins, you just install whatever plugins you need for your work and get started. But on the other hand, if you want to expand your application's functionality, you can, for example, write a little plugin in LUA. Plugins for CAD systems are often written in LUA. Since the ecosystem there is already huge, you might almost never need to do this in your entire career. You're an engineer in a different field, but when you do need it, you think, well, I guess I should go to our company's development department and ask them to write this plugin, and then you estimate how much it's going to cost. You assemble a development team, and in the end, nothing gets written. These days, you can just go and quickly code up such a plugin yourself. After all, there are engineers who have their own personal projects or work projects that aren't tied to security risks or vulnerabilities. They're tied to a lack of tools for the job. And today they can quickly code up these tools, these plugins for themselves, and that's exactly what they're doing. I've already met several people like that, and it's really changed my opinion about coding, because these are truly powerful engineers. Many of them are quite advanced in age, around my father's age. I mean, people who have been working in serious engineering for a long time, but who aren't in the software development domain at all. And these men and women really do use AI tools as a kind of coder's vibe to quickly put together additional tools for themselves. Yes, of course, if something doesn't work, they might try to figure out the code. But since these people are generally very far from coding their engineering expertise in other areas, they don't do that. And vibe coding allows them to write tools, because tools are usually something smaller, little script for automation, maybe a small plugin with a couple dozen files. AI agent systems today handle this surprisingly well. So this class of Vibcoders is growing more and more. Engineers who didn't really need programming for their profession before, but today, thanks to vibe coding, they can write their own tools and make their lives easier. And in this case, I think vibe coding is a separate approach to writing programs. As a kind of programming, one of the branches of programming can be seriously considered without any stigma. So if any engineers who aren't programmers are watching me right now, and I think there are some of you out there, pay attention. Maybe vibe coding will be a big discovery for you and will greatly improve your life. That's it. So now we have a positive attitude toward vibe coders. Well, at the very least, I definitely do. When someone says I'm a vibe coder, I just think good for you. But then someone says, I deployed code to production that AI wrote for me, and I didn't check it at all. And I'm like, okay, so you're an engineer, a programmer, and a vibe coder. In that case, I have some questions. So how is the role of junior developers changing? And in general, what awaits junior developers? Because it's a hot topic. I've been promising to talk about it for a long time, and I need to organize my thoughts. There are two camps here. Some say that nothing will happen to juniors, only the range of their responsibilities will change. Others say that juniors will disappear altogether. I belong to the first camp. The second camp seems strange to me, because their arguments are very radical. If there are no more juniors, the logical question is, how will middles, seniors, and all the other guys appear? And often the answer there is that we won't need either seniors or middles, because all these roles will be replaced by orchestrations of AI agents, which will essentially represent an entire development team. And this team will be managed by some kind of AI assistant managers. And the role of the engineer will kind of fade into the background. Well, of course, we shouldn't rule out such a future. But I think we're still quite far from that kind of future. That's not something that's going to happen in the next 5 years. On the other hand, even if it does happen in the next 5 years, I don't think it will be just like that, with the wave of a magic wand. So in any case, if we keep track of how AI is developing and how our profession as software engineers is transforming, then we too will be able to adapt. If it suddenly turns out that engineers as a whole are no longer needed, then there will still be a need for AI wranglers, so to speak, with engineering skills. In other words, you'll be able to jump onto this transformation train, going from programmer to, say, an AI team consultant or something like that. What else could you call it? Anyway, this is a highly speculative and theoretical topic. There's a lot to discuss here. Of all the more reasonable and thoughtful people in this camp, I probably like the way Byron Manukau articulates his thoughts and talks about it the most. He frequently discusses and elaborates on a specific and important role called the project engineer, a position that is crucial for successful project execution. This is precisely when engineers will effectively manage mixed teams at first, where advanced AI agents will diligently work on implementing some relatively minor features, And then these newly developed features will be meticulously brought to absolute perfection by dedicated teams of highly skilled human engineers. Over time, maybe these teams will become fully AI assistants, but they will still need a human to manage them, someone who knows the domain well and is highly skilled in engineering, in order to prevent all sorts of critical bugs in these systems. And this will supposedly be a mix between a product manager and a qualified software engineer. Combine the two roles and you get a product engineer. In other words, a super skilled driver for an AI team, someone who really understands how to manage these AI teams and is also strong in engineering. Of course, managing AI teams is not the same as managing people. This could actually become an entirely new field. Yes, I believe in such a future in the near term, but again, those of us who keep up with developments in the field will be able to retrain for it. Some might say not everyone will be able to retrain. Well, that's true, just like not every junior becomes a senior. Some people stop, some leave, some are fine staying at the same level. But we shouldn't forget that the amount of software keeps growing and there will be more and more automation. So the number of positions will also increase. Yes, teams might get smaller. This is one of the trends we're already seeing. There used to be large teams, now they've made the teams a bit smaller. The productivity is the same, we keep working. But the number of tasks is also increasing. It's unclear how the rate of job openings correlates with the number of tasks. It seems to me that the number of tasks is growing more slowly for now, but still there will be positions. There will be more competition for these positions, yes. And I think the earnings of such people will increase. But I digressed a bit. All of this was about juniors. So the trend of saying that juniors won't be needed is foreign to me. Because even product engineers, for example, will still need to develop from other engineers, from some junior staff. What can education offer us here? So far, nothing. That is, education isn't changing. We haven't yet seen any cases where after university, even after somewhere like Harvard, okay, not Harvard, let's say MIT people immediately start working as seniors. To become an experienced developer, you need to gain that experience. And in fact, it's precisely to gain this experience that this gradation exists. Intern, junior, middle, senior, there could be changes here. Well, as of today, it's clear that juniors will simply need a broader range of knowledge, because if before a junior was given simple tasks like writing basic CRUD operations, laying out a form, hooking up an API, or writing some tests, now a significant portion of those tasks can be handled by AI, generating that boilerplate code. If previously a junior was expected to produce a certain amount of code, today it's not so much about the quantity of code, but rather the ability to understand that code and bring it to production in a solid state so that the code doesn't have bugs or leaks. What does a junior need to know for this? First of all, you need to know the basics, of course. That is basic knowledge algorithms, data structures, and the architecture, at least for now, of the frameworks you'll be working with at the beginning. Yes, all of this is important in order to understand what the AI has generated. The most important responsibility for a junior today is to understand what the AI generates and to be able to work with it in order to bring it all the way to production. Understanding what the AI generates involves not only having basic knowledge, but also being able to debug that code. That is, even Karpathy, I think, wrote, or maybe it was someone from Y Combinator. Anyway, someone well-known said that debugging skills are reaching a new level. Previously, as juniors, we used to write code from scratch. Sometimes things just wouldn't run for us. Our IDE, our builder would slap us on the wrist, and we'd rewrite things basically working through debugging on our own. Now, when AI generates code, it does it quickly. You'll have to debug more, review more carefully. Accordingly, debugging skills are reaching a whole new level. This is a new, truly fundamental junior skill, the ability to debug code written by AI. At first, this code might be specialized, meaning for a specific language or platform. In the future, I think juniors will be expected to be polyglots, independent of language or platform. It's possible that we'll move toward junior specializing in specific domains. Like, I know how to automate businesses well. I was taught this at university. They showed me how it's done. I'm good at building online stores. I'm good at creating applications for automation. And after that, which programming language we use doesn't matter, because AI can write in any programming language. We know the basics, we know the fundamentals of algorithms, we know the basics of how the devices our code runs on are built. We know how to debug all of this. So with the AI at hand, we can basically write some minimal working code in any technology supported by the hardware and be that kind of junior developer. That's why for juniors, the new skill is the ability to review and debug code. How do you acquire this skill? Well, it's obvious. Of course, as before, you can write pet projects by hand, write code yourself and debug it. But when AI can write this code for you, it makes you very lazy. This is one of the main problems today in educating juniors and probably in career growth in IT in general. In the past, whether we liked it or not, we got our hands dirty and learned from our mistakes. Today, we have to learn, but not from our own mistakes, rather from the mistakes of AI. And that can make you lazy. You mean AI wrote the code for you? Honestly, you just want to send it straight to production without even checking it, so that later the manager will tell you what a great job you did, closing the task in one story point instead of two. That's exactly what you need to get rid of. You need to learn to control your laziness and invest the time that AI has saved you into figuring out what exactly the AI has generated for you. Even if it generates useful code for you that runs, works, and passes all the tests, if you have tests, don't be lazy. Spend the remaining time to understand the code that you simply don't get. It might work, but you might not understand what is this syntactic sugar. Is this some kind of pattern or not a pattern? Who knows? In that case, just use AI as a tutor, as a mentor. You can easily ask the AI about every single line of code, and it will explain quite well what that line does, so you'll be learning in the process. This is actually a new trend in learning. We need to slightly shift our mindset from constantly bothering the team lead and pulling books from Stack Overflow to turning to AI instead. It generates something for us, and we ask about all the points we don't understand. Yes, it's slower. That is, we're not learning from our own mistakes. Learning from your own mistakes is always faster. Moreover, we're typing the code with our own fingers. Motor skills are involved. Here, it will work more slowly, but we process more code ourselves, and we might encounter the same case several times, even dozens of times. By the 10th or 15th time, we'll remember it. So the approach to learning changes a bit, and accordingly, a junior developer ends up with more tasks. But what's the main thing? The main thing is that now what will be expected from a junior developer is not the amount of code, because AI can generate any amount of code, but the quality of code that actually makes it to production, yes, juniors will be given and are already being given higher level tasks than before. In companies that have undergone AI transformation, they hire juniors who by default already know how to use AI tools and can learn from these AI tools. For the company, the benefit of such a junior is immediately clear. Well, first, it still hasn't been possible to replace juniors, and it won't be possible for now. Someone still has to do junior level tasks. For now, AI systems can't handle all tasks, and even if they can, it's only under the supervision of a senior or mid-level specialist. So in the end, you still have to assign a senior or a mid-level employee to work that they didn't want to do. That's why juniors will still be hired, and they'll be given more complex, larger tasks, with the hope that right from the start, they'll be able to bring these tasks to production using AI tools. That's the trend we're seeing. And then there's laziness. Yes, it will be harder to fight laziness when AI writes all the code for you right away, especially during the learning phase. I've encountered this myself. Guys have asked me, but how are we supposed to learn? Before, we used to write code by hand, but now, even if I want to write the code myself, ChatGPT can just generate it for me. So why should I bother writing it myself? Well, why? To learn, of course. You can still write code by hand or ask ChatGPT to write it or not ChatGPT, although juniors might use ChatGPT, but I don't recommend it. It's better to use specialized IDEs right away, for example, and ask everything about this code. If your muscle memory works well, you can simply rewrite what the AI gives you. And some people might laugh at this now, but let me tell you, when I was learning to be a programmer back in 2009, I used to copy code by hand from books. I literally had code listings in books, and I would rewrite them. Back then, it didn't seem funny at all. That was the only way we learned at the time, when there weren't really any chats or interactive groups, and people would reply on forums maybe once a week. The most effective way was to write out code from books, copy it, and see how it worked. You can still do the same thing now, only instead of a book, you'll have AI generating code for you and you can ask it questions. So fight against your own laziness. What else does this change bring with it? In short, a higher entry threshold and new expectations for juniors that's clear, the ability to solve real problems and understand the system as a whole. The fact is, since the bar has been raised for juniors, it will be harder to get in. Yes, getting in is already not easy, especially against the backdrop of all the pandemics, wars, mass layoffs, relocations, moving to new places, new language environments. Natural languages, for those who have moved, yes, it has become more difficult. Entering the field has become harder. But on the other hand, the popularity of programming has also grown in parallel with this. So 10 or 15 years ago, when I was getting into IT, it was easier for us to enter, not because you needed to know a lot more, but simply because this field wasn't as popular back then. Not everyone was trying to get into it, so there was less competition. And the people who chose to go into programming generally had a better understanding of what they would be doing. And many people went into it because they felt it was their calling. Even though I'm not a fan of the idea that only those who absolutely love coding should become programmers. That's how it often was back then, and that made things easier for us. Today, IT is hyped up. It's still hyped. Even here in Europe where I live, it's hyped. No matter what anyone says, IT specialists have a stable salary, a pretty good salary compared to other professions. And it's still hyped. So more and more people are trying to get into IT. That's why there's more demand and more competition. Junior positions. Well, yes, maybe there are a bit fewer now, but there aren't fewer than there were 15 years ago. There's just more competition, more people. And here I can simply say that if you love programming or if you have strong motivation, like financial motivation, for example, if you've moved to a new country and your only way forward is through programming in IT, or if you have some options through programming in IT and you're wondering whether you should go for it or not, maybe you feel like you weren't born for programming, but you have strong motivation. Some motivation other than a love for coding, that's totally fine too. You just need more knowledge, more learning, and more time. But if you, the fly again, if alongside learning the basics of programming, you also study how AI tools work and start using them right away, they can speed up your learning process. Seriously. You just need to try to get used to it, overcome your laziness, and you'll have an advantage. So in this sense, AI both raises the entry threshold and at the same time increases your competitiveness if you don't shy away from using AI. First of all, at the HR interview stage, you're more likely to get hired than a junior who doesn't know how to use it. That's already a given in companies where AI-related questions have been added to the HR process. Secondly, you'll be able to speed up your learning by overcoming your laziness. So always try to look for the positives everywhere. There's always enough work, and there are very few companies that think juniors are useless and that they don't need them. Yes, there are companies that only hire seniors, but they are not the majority, far from it. There are junior positions available. I think they will continue to exist. It's just that the nature of the position itself will change a bit. Perhaps in the future, a junior might be someone who supervises junior agents, but that's already quite an abstract thought. I don't want to go there. There's another risk, which I've already mentioned in general terms, but it needs to be summed up a bit. It's the risk of missing out on the fundamentals. This is the flip side of AI. We're getting used to relying on AI at every step. Again, this shows up at all levels. That's why it's becoming a bit harder now to move up step by step in IT, because we're completely relying on AI. That's not good. ISO, I urge everyone to be a curator of AI, not someone who is completely curated by AI, because AI has a very real ceiling. If you don't try to grow by tackling the tasks that AI gives you to gain new knowledge and instead rely entirely on AI, then your ceiling in terms of your career growth will basically be limited by that AI. As of today, AI can handle junior level tasks, mid-level tasks, and to some extent senior level tasks. Of course, these are rough categories, but when it comes to serious challenges or implementing complex things, it doesn't really manage that well. So you still need to learn the fundamentals. You need to learn the basics and understand the code that AI generates. So for me, the problem comes down to laziness. You need to put in more effort to fight your own laziness and not get used to the idea that AI can do everything for you completely without your checks or your knowledge. Really try to feel this point, laziness, right? Before you couldn't afford to be lazy, because if you were, nothing would work out, you'd get your knuckles wrapped and be fired. Today, if you're lazy, basically AI can implement something for you. You can even push it all the way to production without really understanding it. But at some point, you'll hit the ceiling of your AI toolkit. So there's this risk of skipping the fundamentals. Here we either work on our own laziness or the whole system of training new developers will collapse. But I don't think it can actually collapse. There's also the problem that in general, education today doesn't prepare decent juniors. People graduate from university and they know how to program, they can program just fine. But in most universities, they don't really teach the fundamentals of programming with AI, and that's what's needed. People just recently, I taught a basic course on programming with AI to third-year engineering students at a university in Vilnius. Yes, I've had that experience as a lecturer. I was surprised. The guys were great at programming in several languages, but I was telling them things that seemed super simple to me, like what a cursor is, what context is, how to run models locally and what that means, and what kinds of nuances there are in these models, what MCP is, how it works, what a console AI terminal even is. And for the students, this was all completely new information. So sitting in front of me were solid engineers who were just a bit of experience away from reaching mid-level or senior positions, but they hadn't been given the fundamentals of working with AI tools that could have really accelerated their progress. Specifically in my group, the feedback, at least the ones that reached me, was all excellent. The guys were genuinely surprised that such tools even exist. And you can understand the students. We remember many of us were students, and some still are. When you're a student, first of all, you're absolutely swamped, especially in the early years. And secondly, if you're not in your first years, then your social life adds even more to your workload. So basically, you just don't have time to look beyond your university curriculum. Your life is buzzing with activity, so it's really important that universities today incorporate courses on working with AI into their programs. And you can start small. You can do it like I did, for example. By the way, I taught this course with Vitya, my co-host from the AI podcast. For instance, you can invite specialists like that. Our course lasted just about a month. I think it was 10 classes. But in those 10 classes, the students at least learned what's happening in the market and wrote their first programs with AI. Of course, I strongly believe that this should be integrated throughout the entire program, working with AI little by little in every course, so that when a person graduates from university, they already have an understanding of what AI tools are capable of, how they can speed up their work, what nuances and features they have, and where you need to keep an eye on them. Because today, this is an integral part of any engineer's work in a company that has undergone AI transformation. All companies are now moving toward this transformation. Another major problem with universities that is becoming very apparent now is that they teach for 4 years, and in some cases even 5. Well, there are some that do it in 3. It used to be hard for them to compete with courses that in just 2 years provided enough knowledge to work in production simply by skipping a bunch of general subjects. Nevertheless, in a year and a half to 2 years, you could complete a course and be just as much of a junior as someone who finished an engineering degree. And today, with AI, this time the time to market for a student is accelerating even more. And as we commonly know, established universities are often quite slow to truly transform, especially when the existing faculty is quite orthodox in their thinking and not very willing or eager to adapt to necessary changes. As a direct result, even after a significant period of 5 years, you might indeed learn something valuable, but listen, in 5 years, the industry might change completely and the word programmer might not even exist anymore. Instead, there could be a term like robotics engineer or something similar where programming is no longer the main focus and you'll need to work with entire AI teams either managing them or working as part of them. In other words, university programs are dramatically lagging behind what's happening in the market. You might think that courses could fix the situation, but honestly, looking at what's going on with courses, well, things aren't all that great there either. Courses are these things that are compact, they give you knowledge in a specific area, but with AI, the problem is that from month to month, some new feature might come out that is absolutely essential in production today. And the course just hasn't had time to include it yet. Courses also transform quite slowly compared to the rapid development of AI. Compared to universities, a course is very fast, but compared to the pace of AI development, it's slow. Which of the courses today actually offer a proper understanding of what MCP is, how to write it, how the protocol works, how to write servers, and why any of this is even necessary? Very few. Honestly, I haven't seen many AI courses at all, and even if I have, they become outdated quickly. It's good if the course creator actually earns enough from it and has the opportunity to update it at least once a month. And in this case, you really do need to update it once a month. But there are very few like that. In this regard, the community works well. This isn't an ad right now, as I said. The ad will be at the end. But still, communities work well because there's always a lot of activity. People are constantly bringing in new ideas, new knowledge, and there are regular workshops. Also, in our community, I'm the one doing the code evolution, by the way. Come join us. There will be a link in the description. I've set up some basic lessons there, well, not lessons, but basic posts in our Telegram community. We have a set of fundamental knowledge that ideally you should go through when you join the community just to get up to the level of all the participants and to understand what's happening in AI. And even just maintaining these posts, I have about 15 of them, I think, and they include a few videos and a few files. Literally just 2 files and 15 huge posts. And maintaining this seemingly small infrastructure actually takes up quite a bit of my time. Every few weeks I have to review and redo it. And if it were a course that people spend years making, well, half a year or a year is a normal time to market for a course, and they had to review it every 2 weeks, well, I think that would be pretty tough. So that's why education is a mess, comrades. Education is a mess, and now you have to manage this mess yourself. Well, I guess we'll wrap up here on what beginner developers should do. I hope you understand that it's not the end for juniors. It's just getting a bit harder for juniors to break in, harder to gain that real-life experience. On the other hand, you can gain that experience with AI, and AI can speed up your learning by helping you write and analyze code faster. But new opportunities are also emerging, faster growth, working on more interesting tasks instead of just churning out code. And using AI as a learning tool is also quite fascinating once you start to get into it. So the role of a junior developer won't disappear, it will just transform. The juniors of the future are those who literally from day one know how to work alongside AI or even with entire AI systems and can quickly learn on real-world tasks without being afraid of them. And that's basically it. And the task for companies, universities, and the entire educational system both within and outside of companies is to learn how to nurture these juniors, to learn how to develop juniors who can work with AI and aren't afraid of more complex tasks than what was expected before the AI era. What else did I want to tell you today? I guess I also wanted to talk a bit more about, remind you about the basic toolkit of a modern developer. In my previous videos where I talked about AI, I always mentioned this. I told you about the toolkit. Let's do a quick check-in and refresh our knowledge. Since AI has already been actively used in development for the 2nd or 3rd year now, we've already seen some leaders emerge among the tool zones you really need to be using, ones you need to know how to use. There are literally just a few of these tools. Of course, there are a lot of them. In our Code Evolution community, in the tools group and channel, we already have more than 450 tools, and I still have about 40 more in reserve. But that doesn't mean you need to master all of them. But at the very least, AI coding assistants are essential. That's where it all started. And that's what it's all about now. Forget about ChatGPT, forget about Code AI. Once again, I'm telling you, forget about general purpose chat interfaces. There have long been specialized tools for development. Yes, you can ask ChatGPT to write code. They've even added a canvas there, and you can even run a React app, but that's more for people who aren't professional developers or for some quick casual tasks. At work, we use professional tools. Fortunately, those tools are now available. Well, the first thing that comes to mind for many is GitHub Copilot. I'm not a huge fan of GitHub Copilot because GitHub Copilot is developed by Microsoft. And Microsoft tends to create these strange all-in-one tools that try to do everything at once. And in particular, they've developed the Copilot ecosystem so much that now Copilot is everywhere, not just GitHub Copilot. They have Copilot in Windows, Copilot in Office 365, and even within GitHub Copilot itself, which is aimed at developers, there are a million different branches and features. GitHub Copilot code completion, chat, reviewer bot. Recently they rolled out something new, this MCP, GitHub Copilot. It's just a zoo in there, and in that zoo you're bound to break your leg. Moreover, because it's such a zoo, they don't provide the best experience. All these AI tools for programming are more or less neck and neck, they copy each other, but there are a few that hold leading positions. Just as OpenAI and Anthropic, for example, create top-tier models, there are also companies in programming that make the best tools and everyone looks up to them. Some have their own unique features, but as practice shows, for example, no one has yet surpassed Cursor from the company Unsphere. Yes, someone in the comments will now say, but there's that Windsurf. But comrades, let me tell you, first of all, Windsurf was bought out by Anthropic. Most likely there are already starting to be all sorts of locks there on the models. Yeah, I think in Windsurf you can't use... Oh, actually, did OpenAI buy Windsurf or not? I don't remember. Let me know in the comments. Well, at the very least, they talked about the acquisition, and now you can't use the latest Anthropic models in Windsurf anymore. Vendor locks are a separate topic. Soon we'll see more of these vendor locks as tool makers themselves start releasing tools and locking them to their own top models. So Windsurf has a lot of limitations. At the same time, it's a good IDE. And probably among IDEs, we have AI-first IDEs that have all the necessary features for work, top-tier features that work excellently. There are literally two of them. Those are Windsurf and Cursor among the IDEs we are familiar with. JetBrains, in the previous video, I said that things were really bad with JetBrains. Now, I can say that things aren't quite so bad with JetBrains. There are two teams there. One is developing the AI assistant, and the other is working on Junai, a code assistant for turnkey coding. Two different teams. I know that both teams have great product managers, but for some reason they're lagging behind. JetBrains is lagging behind a bit. I really hope that by the end of the year they'll actually catch up to Cursor's level. But for my clients, for example, there's a new trend in the companies where I consult on how to implement AI transformation for developers. There, for instance, they are moving away from JetBrains IDEs and switching developers over to Cursor, simply because the tools in Cursor operate at this cutting-edge level and other IDEs are nowhere near that yet. That's why Cursor, seriously, first of all, just install Cursor for yourself and pay those measly $20. Obviously, you'll burn through those $20 in just about 4 days of daily work. But you won't be using the AI features in Cursor every single day while you're still getting used to it. Just one nuance. If your company allows you to use Cursor, that's a separate topic altogether. Of course, before joining a company, you should find out which tools you're allowed to use. There are still companies that ban everything, and there are companies that allow everything. You need to be aware of this because there could be data leaks involved. Well, okay, Cursor doesn't actually leak code, but if your company has clients, especially if it's an outsourcing company, they might not be happy if you use AI. So find out what tools you're allowed to use and use them. Nowadays, many companies provide Cursor to their developers for free, so you don't even have to pay for a subscription. The company will provide you with a subscription, and you can use it as much as you want without any restrictions, just so you have an idea of the numbers. Today, developers at companies that have already undergone or are undergoing AI transformation can easily use up anywhere from $100 to $400 a month with Cursor and other development tools. And for now, employers don't deduct this from your salary. Well, they do include it in their costs, of course, but it's not subtracted from developers' pay. But I'm sure that will happen eventually. It's just that for now, there are still few people who use these AI tools so efficiently and effectively that it makes a noticeable impact across the whole company. On the contrary, companies are actually glad when developers spend a lot of money on AI tools and naturally show strong performance. We'll talk more about salaries later. That's a separate topic. Salaries aren't increasing even though performance is higher. Anyway, Cursor is a must-have. Pay $20 and learn how to use it. If your company learn on pet projects if you can't use it at work, because if you change companies, you'll need this skill. If you don't want Cursor, well, you can use Windsurf. Windsurf also has a plugin for JetBrains. Some people say I'll just work with the Windsurf Cascade in JetBrains. Well, I'm a proponent of the idea that Cursor still provides the most complete experience of classic development in an IDE, with the most extensive top-tier toolset. But you'll have to get used to a Visual Studio Code-based IDE, of course, if you haven't worked with them before. By the way, it works for mobile developers too. In my previous video, I mentioned that nowadays, many developers work in two IDEs. They use AI in Cursor. And if they need to compile something or launch an emulator for iOS or Android, they just open Android Studio or Xcode and run it there. But being able to use Cursor is a must-have skill. When I say you need to know how to use Cursor, that's a whole separate video topic in itself. In Code Evolution, I've already done several workshops with the team about what Cursor offers. There's a ton of different features. Basically, it's code completion, tab completion, an agent chat for writing code and sometimes code review. And there you go, there are tons of new features coming out literally every week. The background agents alone are worth it. If you didn't know today, if you have a Cursor subscription, you can assign tasks directly from your phone app. Your GitHub repository is linked to Cursor, and Cursor will work on the task in the background and just make pull requests for you. Sure, it won't implement a huge feature, but fixing some bugs, writing tests, or updating documentation, it can do that easily. And all of this can be done from your phone, on the subway, while you're commuting to work. The assistant from OpenAI is called Codex, and in Cursor, these are called background agents. And there was Deviant who showed all of this a year ago. Now everyone has picked it up. In short, Cursor is a must-have. Let's move on from the trending stuff. And right now, Cloud Code is also getting a lot of hype. Cloud Code is a terminal AI assistant. It's a terminal application that runs directly in your terminal. You just install an NPM package, enter either your OpenAI or Anthropic API key, or link your Anthropic account, and then you work right in the terminal. It's an agent system. What is an agent system? I don't remember if I've explained this before, but it's already basic knowledge, you should know it. So under the hood, you have a lot of tools. Your request is processed, not just a direct prompt and response from the LLM. So Cloud Code is a cool agent system that delivers a turnkey solution. So far, it's the best. If you get the chance, give it a try. Just a heads up, it's pretty expensive. And honestly, if you use Cursor intensively, it can easily cost you $100 or even $200 a month. By the way, this is the new reality. Now more and more pricing plans are popping up. Cursor has a $200 plan, Cloud Code has a $200 plan, Perplexity has one for $200, Google has one for $200, and Windsurf I don't remember exactly, but maybe they have one now too. In Cloud Code, if you walk through the API key, it's very verbose. Under the hood, it uses a lot of agents, and they communicate a lot, so a lot of tokens get consumed, and a regular task can end up costing $2.10. I've even had it go up to $19 for a single small feature that was running for about 5 minutes. So if you're using Cloud Code, spend $100 on a subscription, there you go. Yes, it's a lot. But if you love terminals and want to learn how a top-tier tool that generates turnkey code works and want to master using it, then Cloud Code is your choice. The subscription is $100. Why a subscription specifically? Because with a subscription, the company Anthropic, the company that makes the cloud model, which powers the Cloud Code tool, they offer significantly more tokens with the subscription than they would through the API, apparently to capture the market. People actually compared working with a $100 subscription. They did hit the limit sometimes, of course, but overall, the limits on the $100 subscription were enough to generate as much code as they would have with the API for $1,000 or even $1,500. That's how big the difference is. In this regard, by the way, it's actually more cost-effective to use Cloud Code than Cursor with the Anthropic model, because Cursor still charges per token directly through the API. Well, that's for those who get it. Yeah. So Cursor, Cloud Code, if you want Cloud Code alternatives, they do exist. For Cursor, there's Codex Client from Cursor, but from OpenAI, it's Codex CLI. Google recently released Gemini CLI. There's also ID Try, they have their own try agent, but none of them will give you as great an experience as Cursor or Cloud Code. Actually, we've now split into two camps. even. In short, there are people who really love Cursor, and I'm one of them. Now I work only in Cursor, even with .NET. There are also people who have always preferred the console, and they work with Cloud Code and are very happy with it. And there are people who used to work in IDEs, including Visual Studio Code, and switched to Cursor to Cloud Code because, in their opinion, it works better and handles end-to-end tasks more effectively. That is, Cursor also has agents that can handle tasks end-to-end, but Cloud Code seems to do it more efficiently. I don't have that experience myself. I worked closely with Cloud Code for a few days. It didn't really click with me. I probably need to give it another try. At the same time, Cursor definitely offers a lot more features of a different kind. For example, code completion and tab programming, as I call it, this isn't available in Cloud Code because Cloud Code only generates code end-to-end or rewrites it, that's all. By the way, Cloud Code can also be used as a backend, which is interesting as well. It has an API. You can integrate it into CLI pipelines, for example, and run additional checks on your code during the pipeline, like linting and running tests. Cursor, Cloud Code. And I also really want to remind you that there are AI terminals. The terminal isn't something unfamiliar to me, but my memory isn't very good. I constantly forget commands. I even used to have a little notebook with frequently used commands. But when I started using Warp, which is an AI terminal, I completely forgot about that pain. In short, it's a very simple thing. It's just a terminal where, besides entering a command, you can also switch to what's called agent or ASK mode, where instead of typing a command, you just write something like, how do I don't know, get the commit history for the last 5 days or the last 10 commits. Well, of course, if you know that it's something like git log -5, I think. But if you don't know, Warp just inserts that command for you and executes it. If you confirm, commands, of course, can be more complex. How do you do a grep across the whole project? I don't know. As of today, Warp can even write code in agent mode. They released Warp 2.0 and integrated it with code bases. If Warp sees that you're currently in a folder with a repository, it indexes it and can understand well what's going on in your code. It can even write code, and they've even added diff and other features. It can install things for you. Just yesterday on stream, I was sitting there and I didn't have the UV utility installed, but I needed to run some project through UV. Honestly, I didn't remember. I didn't even know what kind of utility it was. I just typed in Warp install UV. It found information about UV on the internet. Yes, that's exactly what I needed it. Inserted the command itself and ran it. I don't know, you can even ask it to set environment variables, whatever you want. So it can even handle multi-step tasks. It can change directories for you, download the latest version of the code, commit everything with a specific message, and push it to GitHub literally with a single command, or not even a command. You just write to it like, please commit and push the code. That's a really great experience. Unfortunately, Warp isn't allowed everywhere. This too, it's a proprietary tool that requires a subscription. So use it in companies at your own risk. If it's allowed in your company, you can use it. If not, then just for personal projects at home. And still, the console is a bit more of a bottleneck, right? Because through the console, we transmit private keys and all sorts of other confidential information that companies don't want to expose. So while you might occasionally use Cursor in a company, using Warp could be risky. But I insist, if you're in a company and don't know which AI tools are allowed, you should find out first and only then use them. Well, basically that's all the main points I wanted to highlight for development. Cursor, GitHub Copilot, and Warp. Links to them will be in the description. The link to Warp will be a referral link, just a regular referral link. If you register through it, maybe one day they'll send me a backpack. I'd be grateful. I've already brought in 80 people, I need to get it up to 100. And there are a bunch of other different tools as well. For example, when you start working with Cursor, you should learn what MCP is and how you can extend Cursor with various toolkits. You can integrate your own Confluence and Jira with your Cursor, as well as your GitHub and GitLab. But for that, you need deeper knowledge. The simpler ones can be picked up after a few workshops and a few readings. By the way, we have all of this in Code Evolution. You can also go further towards process automation, of course, like reading up on things like Diffie, Nightbot. That's more for automating processes and speeding up your work once you already know how to use AI tools, rather than just learning to work with AI yourself. That's already the next level. Once you learn how to work with Cursor, you'll inevitably understand what context is, how to work with MD files, which files you need to keep in a project, what roles are, and the different types of roles. In short, there's a solid layer of knowledge there, and you really need to acquire it. If anyone thinks this layer of knowledge only takes 2 hours to learn, that's not the case. If you take the full range of knowledge required today to truly consider yourself a full-fledged AI system developer, I'd say you'd need to spend about a month on it, working intensively. If you're studying at a more relaxed pace, I think a couple of months should be enough. Where should you look for this information? That's up to you. Of course, you can try to find some courses. You can search the internet on your own, or you can join a community, for example, ours Code Evolution. We have all of this available. Moreover, you can talk to people, share your own experience, and learn from others. There are different ways to go about it, but the fact remains that you need to acquire this knowledge. If you still haven't used Cursor at the very least, I don't know what you're waiting for, seriously. It's only going to get harder from here. I've already told you a bit about transformation in companies, that it happens from both sides. That is, the integration of AI into teams and the automation of team workflows with AI, including for non-developer teams. There's also a major transformation happening in hiring, of course. I'm not talking about AI filters right now. That's Anton Nazarov's topic. You should go to him for that. I'm talking about changes directly in the interview process nowadays. During interviews, they're starting to ask about AI tools. Again, there's also the topic of gaming the system and cheating in interviews using AI. That's a whole separate area, and I'm not really deep into it. There are other people who can talk about that. I just want to emphasize that hiring is changing in the sense that today, for companies that have undergone or are undergoing AI transformation, and eventually all of them, real preference is given to candidates who know how to boost their productivity using AI tools. In other words, those who know how to work with AI tools. So literally your team leads and seniors, not HR, although sometimes HR as well, really, if they have the knowledge, why not? I mean, the recruiter, that is, they ask about specific AI tools at the very least, about Cursor. You can be sure they'll ask about that. Well, in companies that are more advanced, they ask about GitHub Copilot. Well, never mind. Companies usually ask about the tools they use internally. Many use GitHub Copilot, many use other tools. But overall, if they ask you about GitHub Copilot and you talk about Cursor, I don't see a big problem. I don't see a big issue with that. The skills are more or less similar in both cases. But yes, they do ask about this, they do. Why is this important? Because I've seen real-life examples where an engineer comes to an interview, a good engineer, senior level, absolutely solid in terms of knowledge, but just doesn't use AI. And at this point, there really isn't much of a distinction anymore. If someone doesn't use AI, it's most likely due to some personal conviction. I mean, it's basically impossible to have missed this wave over the past 3 years and just not know about AI. If you're not using it, it means you have some kind of conviction. And that's an immediate red flag, because at the same time, there's the interview result of another senior engineer who does use AI, even though they have a few knowledge gaps. So they choose the second one. They choose the one who uses AI. Why? Because he'll be able to close those gaps quickly with AI, since businesses see developers who know how to use AI as people who will complete tasks faster and with higher quality. That means tasks will reach production faster, time to market will decrease, and salaries will stay the same. This is the main change in hiring. And my last statement probably made some of you pretty upset. It upsets me too. Why on earth, for what reason should we work more efficiently for the same salary? Someone will definitely say that programmers, people like me, are digging their own grave. If no one talked about AI, it wouldn't be spreading. And if you used to do tasks in 8 hours, no one would expect us to speed up. Everything would be fine. But unfortunately, or maybe fortunately, you can't stop technology. And if I'm at least telling you what's new and how to work with it, there are people who just don't care at all and still talk about it. I'm telling you, the developers, how to live with this. On the other hand, I tell companies different things because that's what companies demand. We as companies, we think about how to really optimize teams and developers. So optimization is happening and teams are getting smaller, not through layoffs. But for example, if Vasya leaves for another team or another company, the current team, if it's AI adapted, might not be expanded. They might just add more agents or tools instead. So now a team of 7 people can work just as efficiently as a team of 8. In other words, you understand that for business, AI is no longer towards a means of optimizing costs, and a very effective one at that. We'll talk a bit more about efficiency in a moment. Nevertheless, teams are getting smaller. We're expected to work more and more efficiently. All right, let's actually talk about efficiency right here. First of all, it's important to understand that measuring efficiency when working with AI is still a very abstract thing. What can we measure right now? We can measure what the tools provide us in their statistics. We can see, for example, how many queries a person makes using Cursor. We can see how many tokens a person burns using different APIs, and then compare that to how much more efficient that person has become compared to themselves in the past. This can be done. Setting up this pipeline is actually quite tricky, but companies are doing it. Sooner or later, this pipeline will break, because today you're measuring how Vasya works with AI compared to Vasya yesterday. But tomorrow, it'll be almost impossible to measure Vasya with AI against Vasya with AI. Plus, the tools have become newer, and the models have gotten smarter. And Vasya was already working with AI before, and he's still working with AI now. So it becomes difficult to measure Vasya against himself. So whether we like it or not, some kind of standard metrics will have to emerge soon. They'll start measuring Vasya against an ideal Petya or an ideal Masha, or Ira against an ideal Semyon. Where this ideal Semyon, the perfect developer with top-notch skills, will come from is still unclear. But the point is, evaluating a developer's effectiveness with AI is still a rather abstract concept for now. It's hard to give clear answers about how much more effective the team has become, but everyone is trying to do it. Measuring a person against themselves is another metric you can use on projects where things move quickly. And tasks often reach the market iteratively. This is time to market. If the team's time to market for features or functionality has improved after the AI transformation, that's great. Awesome. So now this team becomes the benchmark, and we measure everyone else against them. As a result, the time spent on a task is reduced. But for now, companies realize that even though the time is decreasing, extra time is needed for additional checks. Yes, of course, the code needs to be reviewed. Sometimes the developer needs to learn something new and so on. So for now, even when developers are given these tools and end up spending, say, $500, people will just come up to them and ask, so what were you doing? If it turns out they were just burning through tokens for no reason, just for the stats, then of course they'll be held accountable. But if it turns out that he closed a lot of tasks and at the same time spent extra time reviewing and learning, they'll say, dude, you're just a top performer, awesome. Because the expectation is that once he finishes learning, he'll work even faster. For business, all this AI is about increasing productivity. What do they expect from us in the future? They expect an increase in resources, productivity by about 1.5 to 2 times. That's the market average. So not 10x engineers, not 100x, not some sky-high numbers, just 1.5 to 2 times. And here, of course, this pain arises. What the heck? Salaries have stayed the same, but the demands on people are increasing. What's up with that? Am I supposed to work twice as efficiently now? But they're paying me the same. It's not about you spending twice as much time. After all, and this is a bit of a slippery slope, but still in companies we're selling our time. Well, that's partly true. We paid for an 8-hour workday. From a business perspective, that's pretty much how it looks. If you can get more done in those 8 hours, then you are expected to do more. But without going overboard, without your heart rate hitting 180 and ending up in the ER without burning out, it's just that. Of course, business would love for you to work like a 10x engineer and pay you like a 1x. But everyone understands that people will burn out, switch companies, and so on. That's why here everyone is searching for the golden mean. What exactly is this golden mean? Yes, for now, your salary stays at the same level. But by working with AI more efficiently, you, first of all, increase your attractiveness to employers. So when new people come in, they're unlikely to replace you unless they can show the same level of performance. Moreover, people who don't understand AI at all and don't want to, and whose performance doesn't improve at all, will eventually be let go sooner or later. But you will remain in demand. In other words, you guarantee yourself this comfortable position, you're keeping up with the pace of progress while others start to fall behind. But it's kind of like, it might seem like, so what, right? I still have to spend more mental energy after all. Yes, that's true. But the industry is speeding up, and no one ever said that in programming you can just study once and then sit back and relax forever. We always have to keep learning, and often that pace only increases. But there's also a slightly more pleasant side to it. At a certain level of learning AI, you start to realize, unless you have a really niche project, because AI still isn't that great at handling super niche things, not as well as it is with something popular like backends, microservices, or popular web services. AI is really good at all of that. So at some point, you realize that you can actually delegate routine tasks to AI. It often happens that you get a task you don't like and you procrastinate because it's super simple, but you have to change something in a million places, write boilerplate code, or cover it with tests. By the way, tests are a great thing in the age of AI. If your project is well covered with tests, then agents just generate the code and run it. If the tests fail, they regenerate the code and so on very well iteratively until all the tests pass. So, by the way, tests might reach a whole new level if before we wrote them just because Uncle Bob said so. Today we might start writing tests because it will speed up the development of new features with AI, and we'll be confident that the AI is writing things correctly. So at some point you start to realize that you can really hand off most of the boilerplate and routine, uninteresting tasks to AI, and you'll be able to work either on the more interesting part of the task or on some other interesting task altogether. In other words, with AI, you'll eventually be able to make your work more interesting for yourself. But this only works for those who love code, who love programming. Obviously, for those people who are motivated by other reasons, which of course are also valid, working on more interesting tasks isn't really a significant advantage. But it is what it is. So what does that leave us with? Yes, we'll need to speed up in the sense that we'll need to become more productive with AI, not just faster. That's what everyone expects from us on the business side. Yes, for now the salary remains the same, but compared to others, we remain in demand within the company. We can work on more interesting tasks, and in the long run, when these transformations are fully implemented, when all HR processes are set up to hire people who are proficient with AI, we'll be even more in demand. After all, competition is growing around us. People who are proficient with AI, those who are skilled with AI tools, are still fewer than those who have just brushed past it or even outright reject it. And there's no trend suggesting that suddenly everyone will become an AI specialist. So it seems that at some point, businesses will keep pushing, and they are pushing. Businesses are pushing for everyone to move toward this AI transformation. I think that at some point, the time may come when developers who are skilled in AI will actually be able to ask for a higher salary during interviews at new companies than those developers who aren't. Then that should happen naturally. Just imagine you come to a company, you've spent a year working at your company, gone through the AI transformation, become a super skilled cursor operator, but your salary at the company stays at the same level. So you think, maybe I'll just change companies. Like, why not? Is it time already? And your salary isn't growing. So you go to another company where, for example, they haven't had this AI transformation, or most of the employees there work without AI. And you come to them and say, guys, I used AI to solve this task. Here are my metrics. Here, I completed the task twice as fast. Here, 1.5 times faster. Here at the same speed. You just bombard them with use cases and bam. First of all, they snap you up in that company. Secondly, you can even get a higher salary by justifying it, saying, look, you're offering me 2, 3, 5, whatever units you're offering me. That's your average salary, for example, at the senior level. But look, I can work at 100%, 1.5 times more efficiently than your average senior because your seniors aren't AI based. So how about you give me not 5 but 6 and they'll give you 6. I'm sure that's how it'll go. Especially now in these years when active AI transformations are happening, companies will be extremely eager to hire engineers who have already worked in this transformed process culture and who are proficient with AI tools. We'll see what happens next. New professions will emerge. Now, of course, if you wanted money, a lot of money, then you should have been an email engineer. These days, Zuckerberg himself is personally calling email engineers and deep learning engineers from OpenAI and offering them signing bonuses of tens of millions of dollars. But not all of us are email engineers, so all we can do is learn AI tools to make ourselves more attractive in the future. And basically, that's it. Some might say, well, whatever, that's all in the future, a year or two from now. Why should I worry about it now? Well, listen, like I said, I've spent this whole episode explaining that if you don't worry about it at all, sooner or later you'll be replaced by Ira or Petya, who are working with AI. That's definitely going to happen. There's just no way around it. After all, businesses want to save money and developers want to work on interesting problems. So saving money on the business side plus working on interesting tasks on the developer side equals an AI-based developer, an AI-assisted engineer. I'm not insisting that this is how everything will be. That's just how I see it, and I hope you understand that. Where is all this going to lead us? At this point, it's hard to say anything specific, but it seems like the automation of programming will keep moving forward. New models will keep appearing. Moreover, people are working on new architectures to significantly increase the context window. If a model has more context and the same computational resources, it will be able to handle a larger amount of code. Agent systems are growing. Right now, under the hood, even in cloud code, several systems are working together. So we don't just go back and forth directly to the models. Our requests are processed, iteratively processed. There's already a fairly complex system running under the hood, and all of this will keep evolving. Possibly in the near future, I think maybe even next year, we'll see, if not fully fledged, then at least partially complete virtual teams. For example, when the front end is being developed by some orchestration of AI agents and an engineer is just there for acceptance testing. But there are already such projects, experiments, not even experiments, but not yet production-ready solutions like MetaGPT, AutoGPT. There are plenty of such projects where you can simply assemble developer teams. Sooner or later, this is bound to become reality. New roles will surely emerge. As I mentioned when talking about Byron Monakova's idea, maybe it's not his original thought, but I really like the position of a project engineer. Perhaps there will be something like an AI auditora person who checks AI decisions for compliance with company requirements, risks, and ethical considerations, especially in critical systems. AI project managers, developers, maybe even AI instructors, in other words, someone who trains models on the company-specific data. But that's already more in the realm of data science and data engineering. But I think, by the way, that data engineers will be just fine. So far, there isn't a major trend of companies actively fine-tuning models for their own tasks. But I think that sooner or later, this trend could really take off, and then developers who train models will also be in demand. It's possible that this will become a basic skill for us, just like context engineering and prompt engineering have become today. So junior roles might shift more towards analytics. Instead of a junior programmer, we'll have the role of an assistant who gathers data and test cases for the AI team. The AI team will process all of this. Why not? A change in the principles of learning programming is inevitable for us. Traditional courses are becoming outdated, universities are becoming outdated, everything needs to change. Impact on the job market. There are two opinions here, yes. For some it's a utopia, for others a dystopia. Some say that 90% of programmers will lose their jobs very soon. Only the so-called architects and maybe a couple of AI operators will remain. Others say that, on the contrary, there will actually be more work. Everyone will be doing only what they enjoy, interesting work, while the boilerplate tasks will be handled by AI. I think the truth lies somewhere in the middle. There will be fewer jobs in the traditional sense, especially at the most entry-level positions, as I mentioned to you. I mean fewer in relation to demand. Not in absolute terms, but in relation to demand. But the demand for top specialists, AI-based engineers, will be increasing. And here, in fact, something rather unpleasant could happen, a division between the rich and the poor, so to speak. Entry-level developers will either earn the same salaries as before or even less, because their role will diminish and become simpler. and senior level seniors, especially those who are also AI based, will be earning significantly more. Meanwhile, the average programmer who doesn't want to learn at all will be left with nothing and become uncompetitive. In other words, moving from the lower ranks to the upper ones may become more difficult. But this division into classes within IT is also a rather abstract concept, which might not even work out, we'll see. Nevertheless, if you currently have the opportunity to aim for roles like AI architects, chief AI officers, product engineers, or AI-based, AI-assisted engineers, then aim for those positions really. Aim for them. If you just want to make money in IT and then go build your own farm or something, that's totally fine. You don't even have to pay attention to any of this. Collaboration with AI as the new norm is something that, well, I already see happening in my own work. I'm literally involved in helping to make these collaborations happen. But I think that within the next year or two, this will become widespread here, and developers will turn into a kind of SIP cyborg developers. I don't even know what to call it. In other words, part of the work will be done by the machine, part will be done by you, and it will all be a single process. No one will be asking, did you write this code yourself or not? Did the AI write 50% of it for you or not? That's it. You have a single team yourself and your assistants working together. And finally, there's the overall evolution of the programmer's role itself. It's possible that the word programmer will gradually be replaced by something else, as I mentioned earlier. Some people are talking about the emergence of the software curator, a curator of software, or a techno-strategist, or maybe an engineer, I don't know, someone focused on solving problems. Not a software engineer, but an engineer for solving business problems. Why not, after all? If we're drawing analogies, I saw a good one with film directors. Directors don't hold the camera or edit the scenes themselves, but they're responsible for making sure the film is completed from start to finish. And often they used to be editors or worked behind the camera themselves, so they have a deep understanding of the entire process. In the same way, will become something like directors or orchestra conductors because of AI tools. And as for continuous learning, we've always had that anyway, but still, in the past, you could pause somewhere and spend 5 years or more on the bench. Well, maybe not on the bench, but at least within your own technological stack. Today, we hardly have that option anymore. And going forward, that opportunity will only decrease because the pace of change is only accelerating. Every 6 months, there are new top-tier models. And to keep up, we'll still have to keep learning and learning over and over again. The good news is that AI is also helping us learn. It can speed up this process, it can even augment us. AI will become our extension, our assistant, and with its help, we'll be able to get up to speed with any stack quickly enough. And by the way, I think that in the future we headed towards stack independence. A senior developer won't be a Java specialist, but a polyglot capable of working with any technology. Because, well, some GPT model, for example, will tell you how to do it. So overall, the trend is that coding is becoming more and more automated. But I think that the role of the human, the creator of the system, will still remain key. At the very least, the demand for humans will definitely remain. So to sum up, AI is not some kind of enemy, nor is it a cure-all. It's simply a new, powerful tool that we need to start using today. It has already changed the rules of the game, the rules of how our profession works. We need to adapt to these rules if we don't want to be left behind. Where should we look for information? How can we stay in demand? The answer is education. As I mentioned before, in my opinion, the most effective learning comes from a specialized community. That's exactly the kind of community I'm building. And right now, I'm actively working on creating a community. It's called AI Dev Hub. It's based on the school platform, if anyone's familiar with it. So AI Dev Hub is a place in English, which I'm currently actively feeding with content. Plus, AI Dev Hub also releases weekly news digests in English, both in text and podcast format. And at some point, there will also be workshops and club calls launched in AI Dev Hub. It's just that for now, we have very few people there. I think once we reach the first 100 members, we'll start live sessions. So if you've always wanted to be part of an AI community where you can keep up with AI in programming, then you are welcome to join AI Dev Hub. The link will also be in the description. Join us. Well, and if you don't feel like joining either of those, just subscribe to the free resources. Let me remind you that I do bi-weekly podcast called Code Evolution together with my buddy Vitya Shlenchenko. There, we talk about all the main AI news. The podcasts are long, 2 to 3 hours each. Also, for my Belarusian-speaking listeners, my friends and I have launched a podcast in Belarusian called Kalasipa Sharbom Sheyu. There, we also talk every 2 weeks about what's happening in the world of artificial intelligence, but without any programming-specific content. In the AI podcast, we still focus more on technical news. In Kalasipa Sharbom Tvaim, together with Evgeny and Emilia, we talk about general news in artificial intelligence so that every Belarusian, even your mother and your grandmother, can go listen and understand what's going on. This is how we popularize artificial intelligence among Belarusian-speaking listeners. By the way, not just Belarusian-speaking ones. I know that my Ukrainian-speaking listeners also understand Belarusian perfectly well, so please subscribe to Kalasipa Sharbom Shai. I'll be waiting for you there. So that's how it is. That's the update. That's how this episode turned out. I think I've never recorded such long talkative episodes in the entire history of the channel. I hope the timestamps will help you. Please don't be too harsh in the comments. Share your thoughts about what you heard today. Be sure to share this video with your colleagues. And of course, don't forget that we're living in challenging times, truly challenging times. But all of this, of course, makes us stronger. But it's not about us becoming stronger and things getting easier from here. Things are gonna get worse. That's what I think. It's a very sad note, but I just want to tune you into my vibes. There's no prospect that things will get better, but it's within our power to at least protect ourselves a little in these completely unstable times. This was Lexi Tiboroda with you, and I hope to see you again soon here on the channel and in all the projects I've told you about. Have a good evening, day, night, and everything else. Bye-bye.
Wow, I'm just finished with this video and it was weird. It was weird and awesome. I believe that you already understand that it was AI generated translation of me. I prepared Russian language video. I put the link to the original video in the description of this video, and then I divided this video to half-an-hour parts and sent it just to HeyGen, one of the first tier of subscription for $20 per month, if I right remember. And HeyGen translated those videos from Russian language to English one. And guys, folks, as for me, it looks cool. You now can hear my English language. You can understand that English language, not my native language, you already know it. And to be honest, from my perspective, my translated avatar sounds much more better than I. And it is weird. As for me, it was pretty quality content, even after translation. Please leave your comments below. Do I need create the same content? Do I need create manual translation of my Russian language video and upload them here? Or it is strange and you don't want to see those videos? But anyway, I think that a lot of thoughts from this even translated video will be useful for you. And of course, in the end, I mentioned about my new community named AI Dev Hub. I'm really working on this community. I spend a lot of time to create this community as good as I can do it. And this is a place where you can, as a programmers, as a developers, you can get to the next level in programming with AI, boost yourself, get basic theory, get all of the news. I really prepare a weekly newsletter and weekly podcast by myself without AI translation with my weird English language. So please connect to AI Dev Hub. Link will be first in the description. It is on school platform. It costs for now $10 for early subscribers. So I'm waiting you there, and let's make the best community for developers who want to boost their productivity with AI Dev Hub. I'm waiting for you. And of course, if this video was useful for you, please thumb up, splash thumb button, put your comment, let's discuss all of the topics that I told in this video. And also please share this video with your friends and subscribe to my personal channel. I'm Lex Kartinnik. I'm not a Lex IT Boroda, as my avatar said. This is Russian pronunciation of English word beard, Boroda. So I'm Lex Kartinnik. See you soon in the next videos. Bye-bye.